MongoDB can be an extremely powerful database choice, as well as an incredibly simple database to set up. But how easy is it to talk to MongoDB from C#? It turns out the answer is very easy. In this video, I'm going to start by showing you just how easy it is to connect C# to MongoDB. We will read and write data to a new database within just a few minutes. Then, I'm going to take you deeper to cover the major operations you will need in the real world, including querying, inserting, updating, deleting, and even transactions and working with the cloud. As you probably know, I'm a big fan of MongoDB. That's why when they reached out to explore the possibility of a partnership, I was thrilled to accept. This video is sponsored by MongoDB, but there's a lot more to it than just a simple sponsorship. MongoDB wants to help the community. And so do I. So we put our heads together and came up with a plan. We're going to use the sponsorship dollars to fund a giveaway of 6 copies of my largest course. But then, since I want to help as well, I'm going to be matching the amount MongoDB is giving away to bring the total copies to 12 copies. But we aren't going to stop there. MongoDB and I are partnering to bring a new full course directly to YouTube for free starting in January. Now, MongoDB makes a great product, as you'll see in this video, but they also make a great partner for the community. I would encourage you to check out the link in the description where you can find out more about MongoDB. The first 10 people who sign up for Atlas, MongoDB's cloud database option, using my link and adding the code MKT-COREY, that's down in the description, at checkout will get an additional $100 in credits. But either way, you can use the free version of Atlas for all of your testing needs. So please take some time to thank MongoDB for helping the community and follow them on Twitter at MongoDB for your chance to win a copy of my course later in December. Now, as with most of my videos, I'm going to create some source code. And if you want a copy of my source code, that link as well is down in the description. All right, let's jump right into the course. So here we have Visual Studio. I'm on 2022. We're going to create a new project. And we're going to create a console app to start. We'll probably stay the console app for the most part. The goal is to focus in on how do we connect C# to MongoDB. But here's the trick. This will work regardless of what UI you choose, with the exception of Blazor WebAssembly. As we know, Blazor WebAssembly needs an API to talk to a database. But otherwise, the rest of the project types, so API, MVC, WPF, WinForms, and all the rest, they will all work the same exact way when talking to MongoDB. So the code we write today can work anywhere. So let's create a console app. We're going to call this MongoDB Demo and MongoDB Demo App. We're going to use .NET 6, which is the current LTS supported branch, or current LTS version, which is long-term support of .NET. We hit create, and we'll get rid of the initial stuff that it creates for us. We don't need that. And now we're pretty much ready to go to start building our application. Now, what we're going to do here is I'm going to first just connect to MongoDB. We're going to get started right away. I want you to see very quickly how to connect and read and write data to a brand new database. That way, if that's all you're looking for, you'll see that in the very beginning. But if you want to go deeper, I'll have that too. So let's talk about Compass. When you install MongoDB locally for testing, you'll get Compass. And Compass allows you to connect to your local database or to the cloud. I actually have a connection for each of them locally. So I can connect to my local database or our local databases, actually, this is a local server, or my cloud server on Atlas. Let's start with the local database. Notice it's localhost with a port of 27,017. That's the default. We'll hit connect. And here you can see I have a bunch of just test databases that are set up. We're not going to create a new one, okay? We're not going to create a new one through Compass. We're going to do it right through code so you can see how easy it is. So right now we have test suggestion app, test DB, testing, local, demo, config, admin. This just means I've been doing a lot of testing with MongoDB and playing around with it recently. I just reinstalled on my computer after having upgraded my computer. So with all of this, notice that we don't have a database called SimpleDB. That's the one we're going to use today. So there's no SimpleDB database. All right, let's go back over to our code. And if you want, start the timer. It's only going to be a few minutes to get going. The first thing to do, right-click on dependencies, say Manage NuGet Packages. You're going to search for MongoDB.driver. And this one right here, MongoDB.driver, is all you need to install in order to talk to MongoDB. Now, if you're not familiar, MongoDB is a document database. It's different than SQL Server. We're going to deal with documents instead of dealing with tables. It is a different philosophy. We'll get more into that as we go deeper into this video. But for now, just note that it is different than SQL. Okay, I need two using statements. First of all, using MongoDB.driver. And then we're going to add another class in here. So I want a using for MongoDB demo app, which doesn't exist yet, that namespace. No worries. We're going to right click and say add new class. And we're going to call this the person model. And I'm going to change this over to using quick actions refactoring, the file scope namespace. I just like that a little better. So with this, let's make this public. And we're going to add 3 properties in here. A string ID, not an int. A string first name. And if you notice, I'm using prop. That's a snippet that allows me to quickly create an auto property. String last name. So that gives me my 3 properties. This is just a very, very simple setup for testing out how we're going to read and write. Now, up here above my int, I want to add 2 decorators. First, bson ID. Now, control dot to add that using statement at the top. And second of all, I want to add a bson representation for bson type dot object ID. Now, we can shrink this down by just doing this and having a using statement at the top. So let's just control dot there and add that using. So now we have 2 usings up here. We have one for MongoDB.bson and one for MongoDB.bson.serialization.attributes. Now, what's going on here? Well, I'm decorating this model to say that this right here is my unique identifier. Now, in SQL, we have the auto-incrementing value that we use an integer for traditionally for our ID. In a document database, it's a little different. And part of the reason why is because a document database is designed to be used around the world with synchronizing databases, and it's a lot more complex in some ways, but in some ways it's a lot simpler because we can use a ID that's an auto-generated ID that's unique across the world. And then with that, we can have multiple databases that are taking in new data all the time without having to keep track of, oh, I gave number 1 to that database, number 2 to that database. Oops, I have a number 3 on both databases that are being inserted. That's a problem. Not to worry, with this ID, it's a globally unique ID based upon basically the probabilities, okay? So in very, very small chances, there might be a repeat, but probably not. And probably not, I mean like billions of chances. So with this, it's going to create an auto ID and it's going to say, hey, this is an object ID. Now, when this data gets stored in MongoDB, it's technically stored in what's called bson, which is like JSON but binary. And so we say, hey, this is a bson ID, saying this is the identifier for this record. The cool thing about a document database is that you don't have to have a given structure for a document. You can put different documents in the same collection, and it can be okay. Now, typically don't do that, at least not radically different documents. But with this, we're saying here is the structure of my object. And by the way, this right here is the unique identifier for the record. Okay, so that's all that decorator does. It will take care of putting the ID in for us. We don't have to generate that ID if we don't want. With that, we can go back to our program.cs, and now we should have MongoDB demo. Oh, you know what? I put app at the end of that. There we go. That's the right using statement now. So with those two things, we now need to connect to our database. Normally, I would use a app-settings.json, but because we're moving quickly on this, let's just say string connection string. And we'll put our connection string in here for MongoDB : /127.0.0.1, and then our port number 27017. And again, this is pretty standard. So that's our connection string. Again, I would use app-settings.json to pull that normally, but for a simple demo, we can just put it right here hard-coded. String database name equals simple DB. Remember, that's not created yet. And then string collection name equals, let's go with people. Okay, so now we can say var client equals new Mongo client. Actually, there we go. It auto-completes for me. Var DB equals client dot get database, and there's the database name. Var collection equals db dot get collection, and we'll pass the collection name, but we're going to give it a type. Person model. So what we've done here is we've got a connection to MongoDB using that connection string. We've connected to our database, which again does not exist. So it's in a list of database names, doesn't exist yet. That's okay. Then we're going to talk to a collection. Think of a collection somewhat like a table in SQL. It's different, but it's similar. It's going to hold a set of data that has a relationship to each other. So now, var person equals new person model, and we'll just fill in first name equals Tim and last name equals Corey. Okay, real simple. Now, await collection dot insert one async person. Guess what? We are now done. We have written something to MongoDB. Now, I haven't run this yet, so it's not actually performed that action, but that's it for talking to MongoDB. We have to set up our connection, which database we want to talk to, which collection we want to talk to, and then just say insert one async, and it will insert this record, which we just created. Now, just inserting a record is not quite good enough for me. Let's say var results equals await collection dot find async. So we're going to find something. And this is a little bit of an interesting syntax, but what we're saying is we're going to pass in the query. What things we want to look for? What's the filter criteria, which we don't have any. So what we're going to say is, this is a discard character, meaning I don't care what this variable name is, I'm not going to use it. But I want you to return a record where true is true, which means basically return every record. That's what find async is going to do, is going to say, okay, here's the criteria for filtering. Oh, every record. That's it. Okay, so we're going to return every record. And let's do a for each. Var result in results dot to list. So make that into a list. And then from here we can say console write line. Let's have our string interpolation. We'll have result.id. We'll put a colon space result.firstname space result.lastname. That'll be it. That's our entire application. It fits in 21 lines of code, if you take out this extra space up here, 21 lines of code that inserts into a database that actually gets created as we do, and then it reads out of it the values. Let's see it in action. There we go. So it says, here's the ID, and then here's the name. If you go to Compass and we refresh, we'll see we now have a simple DB database. Inside there's one collection. Inside there's one object ID. That's our ID field. And the first name is Tim and the last name is Corey. Just to prove this is really a case, and let's see if we can't zoom in here a little bit. That's a little small. I can double click here and I can modify this to say Timothy. Now, we didn't do that in the code, we did that in the database. And again, every time we run this code, it's going to insert a record. So let's run this again. And now I can see a different ID. One says Timothy, one says Tim. So now we can see that we are inserting the database and we're reading back out of it. That's really how easy it is to talk to MongoDB. But we're going to make it even more clear as we expand into all the things you really need. Because probably you're thinking, okay, I can do inserts and I can do reads. What updates? What deletes? Or you're asking for every record, how do I filter? And what if I need to insert into more than one collection? Which, by the way, isn't something you should be doing very often. We'll get to that in a little bit. But I can see all those questions. I've heard all those questions, and I'm going to show you how to go even deeper. So that's our initial demo. You can see how to connect to MongoDB, but we're going to go even deeper and look at all the options you could do with MongoDB. Now, to do this well and not waste your time, what I'm going to do is I'm going to copy and paste just a little bit of code just for models. So let's create a new class library. So we're going to create a class library. It'll be a .NET 6 class library. We're going to call this Mongo Data Access. And yes, .NET 6. In here, we'll delete class 1. And we're going to create, let's try and set this up mostly correct. So data access, this is a demo, but at the same time, I do like to have my demos be actually workable code. So let's create actually, before we do this, let's create a new folder called models. And in here, I'm going to create a user model. Well, you know what? I'm going to show you something really quick. We're going to, on the solution, right click and say add. Let's get the editor config in here. That way, just close it out and reopen it. It, for some reason, doesn't open the first time. Change the code styles and go to file scoped. That's it. So now, once that gets applied, this should create for us file scope models. We're going to create the user model here. And it didn't the first time. It does this once in a while where it doesn't set it up correctly at first, but then it will update. So mark this as public. And here is my code. Let's install the MongoDB package, not MongoDB.bson though. We want to go back to manage NuGet packages. MongoDB.driver and install this. Now, there is no way of doing this. I'll hit install here, but since we already had it in the other project, which, by the way, we don't have to if we just call this class library, but since we have it already there, then what we could do is we could go to our project and see this right here, this item group where it says MongoDB.driver in package reference. We could copy this whole thing, come over here and paste it in here, and that would just apply that NuGet package as well. It'd be a shortcut. Okay, so there's our user model. ID, first name, last name, and full name is just a first and last name put together. And that's a read-only property. So that's our first model. Our second model is going to be a chore model. And there you go. See that the file scope namespace worked that time. And in here, we'll make this public. We're going to, again, I'll grab and copy from my other project and paste it in here, just because you don't need to see me retype all this stuff. This is and notice it added the using statements because it now has that package. Therefore, it knows where they came from. But ID, chore text, frequency in days, assigned to, and last completed. So this is a little demo I built. We're not going to do the whole demo. We're just going to do the MongoDB and data access side of things. But what this does is it's a chore system. So if you have chores around the house, if you have kids that have chores as well, maybe you're splitting up the duties in the household, you can say, okay, I need to mow a lawn every 7 days. You put that in a list under your name. And then what will happen is we will track when it gets done. You'll say, yes, I just did this, or hey, this one's due. Let's go ahead and do that chore. So it's a nice little tracker that works for multiple people. So you can track not just yourself, but yourself, your kids, your spouse, your whole family if you want. So that is the chore model. And the last one is going to be the chore history model. Copy that code and then come over here and say add new class, chore history model. Make it public. I'll get rid of the usings that we don't need. We'll paste in that code. Again, it's going to add those 2 additional usings. And now we have ID, chore ID. We have the chore text, date completed, and who completed. I also have 2 constructors here. One that's the normal blank constructor, that's just empty, but then one that takes in a chore model. So you pass in a chore model and it says, okay, let's create a history event for that chore. So we will update when the chore was last done, and we'll update who it's assigned, or we grab who it's assigned to in the text, and we'll create a model off of that. That way, we can very easily create a history entry when we update the chore, saying, yes, I just completed this. So those are the models. Let's close this down, and we'll close this one as well. So those are the models for our new demo. And now what we're going to do is we're going to create some data access. We're going to create a class. Let's call this just chore data access. We could get a lot more specific here and make this work with both, SQL and NoSQL. MongoDB, by the way, is a NoSQL database, but we're just going to focus in on making this a MongoDB database. So we will add a using up here for, let's go with, it's called MongoDB data access dot models. That way we have access to those models. And we also need the using for MongoDB dot driver. And that'll be for accessing MongoDB stuff. Now up top, what we're going to do is we're going to create a few constants for our different things. Like for example, our database name, our connection information, and so on. So private const string, and this will be the connection string. And again, we would normally pass this in. So normally we would grab this from a iConfiguration, but we're going to hard code it just for sake of simplicity. And so for now, we'll grab that from over here. Let's copy it, paste it in. There is our first const. I'm using const because they're a little more efficient when it comes to memory usage. We're not going to change these values. These are just putting them up top so that they never change and we can reference them multiple times. If we do need to change the value, we can change it in one spot. Okay, private const string database name, and we'll call this our chore DB. Let's make sure there's no chore database already in our list. Let's go back to our databases and look, and there's no chore. There's admin. Let's zoom in here. Admin, config, demo, local, simple DB, and so on. No chore DB. So chore DB it is. And then private const string, let's say the chore collection equals chore chart. This is, remember, collections are kind of like tables. Private const string user collection equals, let's call it users, and private const string chore history collection. Chore history. Okay, so now we have 3 different collections we can talk to. Again, we have not created these in the database. We haven't even created a database. That's okay. The first time we use a database, if it doesn't already exist, it will get created. That's the difference between SQL and a NoSQL database like MongoDB, where we don't have to have all of this confusing or set up beforehand. No configuration, SQL statements, T-SQL, all of the declarations of what should be where. Don't need it. All we need to do essentially is say, hey, here's data. This is where it should go. If it doesn't exist, create it. And the cool thing is, when we passed in that person model, it just created a person object for us and put it into the table. It created a structure for us. So when we come over here and we want the chore collection or the users or the chore history, no problem. It'll create those 3 collections for us and put data in those collections that we give it. When it comes back out, it comes right back out in the same structure. It's very, very easy. There's no translations to it. Okay, so now notice that in program.cs, we have this setup. And we have to do this setup for every collection. So instead of doing that every single time in every single call, I'm going to create a private IMongo collection of type T called connect to Mongo type T in string collection. Now, this is some advanced stuff. We're using generics here. We're also using a little used keyword called in. Now, in was added in C# 7.2, I believe. It's kind of like ref, where it passes a reference, but the difference is we cannot modify it once we pass it in. So what we're going to do is we're going to use this to pass in our constants. That way, we're not creating a copy of them. We're not allowing them to be changed. It will be just a little bit more efficient. You don't have to do this. You could leave off the in, it would still work. But this is a little bit of an efficiency boost for us. And with strings, the more efficiency you can have, the better, since they're pretty inefficient objects. Now, the generics, what we're saying is we're going to pass in a type. And what I want to get back is a collection of that type. So this allows us, notice we passed in right here, person model for the collection. Well, we're going to pass in that type and get back a collection of that type. That we can pass in 3 different ones: chore history model, chore model, and user model, and get back the connection for each of those. So var client equals new Mongo client. And we're going to pass in our connection string. That's the constant. And then we're going to say var db equals client.getDatabase of type database name. We're going to assume we're only using one database here, not multiple databases, which is most common, just to use one database. Return db.getCollection of type T, passing in collection. So we're going to pass in this name, which is either chore chart, users, or chore history. We're going to get that collection, and it's going to be of that type. Okay, so that's our setup. We're going to do over and over and over again. We can just do once now in one private method. Now let's create some connections or talk to MongoDB. So private async, we'll make everything async. Task of type list of user model. So we're going to return back a user model, and we'll say get all users. Like so. And then in here, we'll say var users collection equals connect to Mongo of type user model, and pass in user collection. So that's now, this line right here represents these 3 lines of work. So one line is what we've done, we reduce it to. And then we have var results equals await user collection dot find async. And again, we're going to say, I want you to find all of them. So it's a get all, therefore we don't have to filter this in any way. Return results dot to list. That's our get all. That method right there gets all the users. Now let's keep going. We've already seen that once. So let's do some more. Public async task list of chore model, get all chores. And it's going to essentially be the same thing as this. Let's copy and paste. But this time it's going to be chore model, and we're going to pass in the chore collection. Like so. And we should say chores. This is why copying and pasting isn't always the best option, but it's essentially the same thing, okay? It's the same pattern, it's just now for all chores. And we'll stop there and then get alls. We don't have to do every method here or everything they would do in a normal database. I just want to get you the main things so you can see the differences. So how about public async task type list of chore model? But this time what we're going to do is get all chores for a user. It'll pass in a user model user. So it's going to filter our search. So just like the chores up here, we're going to do something similar. So let's copy and paste it. That would be returning everything, but we don't want to return everything. So instead, we're going to say, instead of this filter where everything is true, we're going to say C instead of that discard character, because we do want to see the model. So C dot assigned to dot ID equals user dot ID. Now what's going on here? Well, this is going to say, I want you to look up all the chores, but filter them where the assigned to ID is the ID of the person we just passed in. So if we look at our models, the chore model has assigned to. And in that, at the user model, so in that we have an ID. So it's looking at a sub-ID. It's looking inside of a collection, inside of an object, into that object's property. So object, sub-object, property, and comparing that to this value and saying, hey, if they match, return those results. So that's how you filter by some type of data in your model. Now, let's go on. Let's look at inserting some records. So public task create user. User model, user. Notice I'm just saying public task because I'm going to return this without awaiting it. So var, well, user collection, we can just grab that from up here. that connection string looks, or the connection information looks the same every time. So return user collection dot insert one async user. That's it. That's how we create a user. Let's do the same thing with a chore. Just so we have both of these so we can actually test this. Public task create chore model, chore. There's our chores collection. Return chores collection dot insert one async. And again, IntelliCode is starting to learn what I'm doing and anticipate my needs, which is awesome. Next up, let's do public task update chore model, chore. And in here, again, the chores collection, but now we need to create a filter. Var filter equals builders for chore model dot filter, dot eq for equals id chore dot id. And that's saying, okay, we want to filter this where we're saying only update the record where the ID matches this ID. So we're updating a record. We're passing the whole record in, including its ID. We're going to grab that ID and say, hey, this is what we're going to update this record. And since that's a unique identifier, it will only update one record based upon this match. This is going to filter to only match the ID that you pass in. Now, return chores collection dot replace one async. We pass in the filter, the chore, and then we're going to say new replace options is upsert equals true. And that kind of scroll off a screen. There we go. So what that does is it's going to find that record. And it's going to say, oh, there's an update to it. So we're going to replace the whole record. So it's going to remove the old record, put the new record in. That's the update. And then if it's does not exist, it's going to insert the record. That's what an upsert is. It's either an update or an insert, depending on what you need. So this way, even if it doesn't find it, it's going to say, oh, well, it should be there, but if it's not, no problem. We'll just go ahead and insert it. So why are we doing a full update? Why are we replacing the whole object instead of just the fields we need? Well, because it's still super efficient. This is not like SQL where we have to go through and insert a whole bunch of update, this table and this spot and all that kind of stuff. We just pull out a JSON document, or BSON technically, but it's JSON for what we see. Pull out a JSON record and put a new one in. That's super efficient. So it's actually more efficient just to do this than to try and figure out a way to update individual fields unless you know for certain which fields need to be updated. Now, with this, I do want to point out that MongoDB is different than SQL. I want you to concentrate on that. Don't just bring your relational database ideas and try to apply them to a non-relational document database like MongoDB. This update, what we've done is we pulled all the data down from MongoDB. We have made changes in C#. We're just going to put the whole record now back. So this isn't going to lose data. This is just going to update a record. Okay, so that's how we do the update. Let's go on to delete. Public task delete chore. Now, this is not something we often do, but I did want to show it because in the event that you do have to delete something, I want you to know how to do it. Okay, so normally we'd just say mark it as archived or move it out into an archive or something like that. But we are going to, in this case, delete a record. So return chores collection dot delete one async, where we say c arrow c.id equals chore ID. So what this is doing is saying delete one record based upon the ID of that record matching the ID we're passing in. We have the ID from the chore. We're saying just match the ID and just delete the record. We don't have to pass the data in beyond that. We're just saying these two match, then you're good to go to delete, since that's a unique identifier. That's all we have to do for delete. So we now have a full CRUD access to MongoDB. We have creates with our inserts. So that's what we're doing right here, where we create our users. We have reads, which would be our get and get all. So we have get all. We also have get with a filter on it. And then we have our update and we have our delete. That's full CRUD access. We can make these calls right from here. So we can comment out most of this stuff. And we can reference our library. So we just right click on our project and actually, let's go to dependencies. How about that? And add project reference. Check the box for Mongo data access. And now we can start referencing. We just need to create a chore data access. Control dot to add that using. Let's call it DB. Not data access, DB equals, there we go. And now we can start working with our chore data access. Now let's add a using up here for Mongo data access dot models. Now we could use the global usings for this. It depends. I'd probably put the models in global usings, but that'd be about it. So now we can say db dot create user. We can pass in a new user model, and let's say the first name equals Tim and the last name equals Corey, like so. I think that's all the information we need for a user model. First name, last name. Yep, that's it. So we can create the user, and let's just run that. When we do, it just says, hey, you can close the app now, it's done. We can come back over here, refresh our databases, and we'll see that, what do we call it? The chore database. That should show up here shortly, if we named it right. Let's try reconnecting because I may have broken something. Okay, localhost, connect. It's not showing up. It may be I put it in the wrong database. Let's find out. So let's go over here to the chores. I call the name choredb. Of course, this comes down to a dumb error on my part. I did not mark these as asynchronous, so I forgot to await. Now, you could mark all these as async. I prefer not to do that and just make everything async, but it's really up to you and your preferences for if you want to mark things as async. Just a reminder that, hey, you need to await that call. So let's try this again. This time we will build, we'll wait for it to run, same amount of time. We'll come back over here to our databases, we will refresh, and now we have a chore DB with a user table with one object in it that is Tim Corey. Cool. So now we've got one user that we can then look up. So we can say db.get all users. Do we have a get all users? If not, we need to create one. So yeah, get all users. We marked it as private. Always watch the modifiers. So public get all users. So Control J here to bring the list back up, and now get all users. And again, we need to await this. So we're going to say home var users equals await get all users. That's going to give us a list of user model. And from there, we can create a chore. So var chore equals new chore model. And we're going to say assigned to equals, we're going to kind of cheat here just to get something going. Users.first, well, just user.first. And that will grab the first user in our list of users from a database. And the chore text equals mow the lawn. Let's unpin this. And what else do we need to add here? Frequency in days. Yeah, every 1 day is kind of excessive. Let's do every 7 days. Like so. And last completed, we don't have one of those. We're just going to say, whenever. So we haven't done it yet, therefore it's not completed yet. We can, let's bring this down here and make this look a little better. Like so. That way it's a little prettier. And now we can say await db.create chore and pass in that chore. So now we'll create a chore from that chore list. And let's just run this. It's going to create another TimCorey. That's okay. It's already done. So let's bring up our compass, which I believe I just closed. That was a mistake. No problem. We will load Compass back up. You can see again how to log into Compass. Grab your connection to your local host and hit connect. And in here we have our chore DB. We now have a chore chart. And on here, we can see that mow the lawn, frequency is days is 7, assigned to is TimCorey. Now you may notice that this has actually copied the data from my users table. So I have an entry now in the users table called TimCorey, actually 2 of them now, but I have in the assigned to, I have TimCorey as well. And you may say, ooh, that's duplication of data, that's not dry, that's a bad thing. And it's not. And here's why. With SQL Server and all relational databases in general, that includes MySQL and SQLite and all the rest, the relational data model is all about saving space. It's about saying we're only going to write things to disk once. And we're going to do that at the expense of time. Because we're going to break apart these things into their various parts and then link to them using IDs. So when it comes time to write to a database, you may have to write to 3, 4, 5, 10 different locations at once. Because you have to write addresses to their own table and phone numbers to their own table and email addresses to their own table and the person record to their own table and then link all those together. Whereas in a document database, we store all of the information together as much as possible. We do occasionally link out. And in fact, there is the ID here, so we can create a link if we need to, if there was additional information about that user that we wanted to look up. We could actually use that ID to look up the user. But we want at least the information that we're always going to want with the chore to be with the chore. Because non-relational databases, or NoSQL databases, are going to focus more on speed, data access speed. The idea of how fast can we get you back the data. That means we don't write to a lot of different collections for one record. We want to write to, ideally, one object. That's it. We don't want to have collections all over that link to each other because that's inefficient. Now, it does mean a duplication of data, and we do have to know what is the primary data. Well, in this case, assigned to has that object ID. So what's saying is, this is not the primary record, but I do know where that is if you wanted to update. That way, if later in the users section, we updated Tim's name to Timothy, we could, in theory, go back and update assigned to reflect that new name. Now, it was assigned to Tim when Tim was calling himself Tim. Yes, we could go through an update, and we probably should, but we don't have to. If this is just for historical purposes, then it's not necessarily necessary to do so. But what this does is it allows me, when I'm looking for just the information on a chore, I get all the information, all the linked information, all in one spot with one call with no filtering. I just have to say, hey, that's the record I want. I get all the data about it. That makes it much faster. We are sacrificing disk space for speed. That's the trade-off here when it comes to relational versus non-relational or document databases. So there are benefits to relational databases. There are benefits to NoSQL databases like MongoDB. Which you choose does depend on the situation, but just note you need to treat each the way they were designed, not the same way. Because if you treat them the same way, you're going to get bad results. So that's my little bit of soapbox for today. Let's talk now about what if we wanted to add one more thing here. Right now we have the concept of chore history. But when we write to the chore history, we also want to update this last completed field to not be null. But that means updating two different things. Let's start by looking at one way we could do this. All right. So one way we could do it is to say public, and let's call this async task of complete chore, and pass in the chore model. So we're going to say, hey, when you're ready, go ahead and pass in a chore. We'll say that you've completed it and put it in the history. So we're going to say, let's grab the chores collection and say var filter equals builders.chore model, or I'm sorry, builders angle bracket chore model dot filter dot eq and ID and chore.id. So we're going to say, hey, I want you to find the chore based upon its ID, and we're going to do an update. So await chores collection dot update one async. I'm sorry, replace one async. We pass in our filter and our chore. And we could just do that. We could also do the is upsert, but I think we're just doing an update of an existing chore, so we should be good. So, but that's only part of it. We've updated the chore to say, hey, here's the new chore information. By the way, that's going to have the new updated time to it, hopefully. But that's not it. We now also need to do an insert. So var chore history collection. We haven't done this yet. Connect to Mongo chore history model and pass in the chore history collection. Thank you, IntelliCode. Await chore history collection dot insert one async new chore history model. But the cool thing is we can pass in chore, and that will set up our chore history. Remember that in our chore history model, we have that constructor that takes in a chore model and it builds a chore history entry off of it. So that's how we could update and insert. But that may not be ideal because we already had two different collections. What happens if we have an exception on this line? Well, we wouldn't write the chore history. We'd update the fact the chore was done recently, but we wouldn't know by who or how because the chore history was not updated along with it. So that's not ideal. So what do we do? Well, this is where we would bring in a transaction. The problem is that locally, we can't use transactions. So in Compass, if I were to try and use a transaction, that won't work because we've got a standalone cluster. For a transaction to work, we need to have an actual cluster with 3 different databases. MongoDB is great about working in the cloud with multiple databases, even spread out across geography, so that we can have a really responsive database that is synchronized. It takes care of setting up the primary version versus the backup versions and all the rest of that stuff. But locally, we just have one copy of our database. So we don't have that redundancy. So we can't do a transaction locally. Well, this is where we can bring in Atlas. So Atlas is the MongoDB in the cloud. Now you can put Atlas into AWS. You can put Atlas into Azure. You can run Atlas directly. So it's up to you how you work with Atlas. Notice down the links down below, I have a link to sign up for Atlas. Remember, you get the first 10 people that use that coupon or that ID code will get $100 of credit for Atlas, but there's also a free version of Atlas that you can use during that sign up process. So you can have your own free version to test out these things. So the first thing we're going to do is I'm going to connect to Atlas, and I'm going to run this same code just to show you that it does work. But in order to do that, I need to put my connection string up here. And it does have a little bit of security in there. I'm passing in a username and password. So what I'm going to do is I am going to not show you that, even though technically it's locked down to my IP address. I still want to not show you that just in case there's any problems or it gets out. So I won't show it to you, but I'm going to put it right here, and then we're going to come back over to program.cs and run the same thing over again, and we're going to look at my Atlas installation. So let's do that. All right, so I've now set up my connection to Atlas. Let's go back over here. We're going to create a new connection, and we're going to connect to, this time, Atlas. So here's my Atlas connection string. Notice it puts stars in the place of my password. I hit connect, and now I'm connected in the cloud, and I have 4 databases in the cloud right now. Let's move this off a screen. We're going to run this app, let it run, and it's completed already. Let's go back over to Atlas. We'll refresh, and now we have a 5th database called ChoreDB. Inside there we have a chore chart with an assigned chore. Let's zoom in here so you can see it. There's our mow a lawn chore, frequency 7 days, assigned to TimCorey. We have just that one user for TimCorey. So it has set up our database in the cloud, our 2 collections, and now we're all set. So now what we need to do is work on making this chore or complete chore to be transactional. I'm going to comment this out. This will work, but it's not transactional. So again, if you crash halfway through, you'll lose your consistency. So I don't like that. And ideally, we would have a transaction. But again, I'd want to stress this very, very clearly. Just because you can do transactions in the cloud does not mean that you need to think about databases in MongoDB the same way you do in SQL. If you are doing lots of transactions, you're probably doing it wrong. I hesitate to even show transactions because there is a idea that we want to abuse this and use transactions the same way we do with SQL. But there are times when transactions are necessary. In those cases, I want you to know how to do it, but just note you shouldn't be using transactions for most things. So var client equals new Mongo client. And we're going to grab that connection string. Now, note that I'm not using my connect to Mongo setup. That's because we need to start a connection, and then we need to set up a using statement where we say using var session equals await client dot start session async. So this is a using, so that means that once we get to this end curly brace, it will for sure close out of this session. That's what we need to do. And then we need to start with our, let's scroll up a little bit, our session.start transaction. Now, if you're not familiar with transactions, what happens is a transaction is an all or nothing thing. If you are doing two different actions in two different collections and you need to make sure that both things happen, then you use a transaction. Think of this like using a bank account. Here's a classic example. If you are withdrawing $100 from your savings account and putting that $100 into your checking account, you want to make sure that both actions happen. If you withdrew $100 from your savings account, but then the application crashed, you would just lose $100. You want to make sure the second half works. Otherwise, don't do the first half. So the same thing is true here. We're going to start a transaction, and if everything goes well, we're going to say, go ahead and commit that transaction. But if any error happens along the way, we're going to say, nope, roll back everything. So we need a try catch, and we'll grab the exception, and we are going to remove the throw for now. So inside of this try catch, we can say var db equals client.getDatabase database name. Whoops. And then we say var chores collection equals db.getCollection chore model chores or chore collection. There we go. So it's going to connect to our chore collection. And we're going to do basically the same thing here, that filter and await. Let's just copy and paste those things in. So we're essentially doing these tasks up here, but wrapped in a try catch with the session. And we're also doing manually connecting to our database in our collection. All right, so we're doing our filter, we're doing our replace, and then down here, we're going to say var chore history collection equals db.getCollection chore history model, and then the chore history collection, and then await chore history collection dot insert one async new chore history model, and we're going to pass in the chore. Again, it's going to create it for us. Now at the very end of this, we can say await, this is very important, session.commit transaction async. Now that's the happy path. The happy path is we connect to our database, we create the session, we start a transaction, we update or replace our chore, we insert a new chore history entry, and then we commit. But what happens if we throw an exception anywhere in here? Well, what we're going to do here is just say await session.abort transaction async, like so, and we will do a console write line that says ex message, just so we can see the error message. That's it. We now have our complete transaction. So we have our start transaction, we have our commit transaction, and we have our abort transaction should anything go wrong. With that, we can now complete a chore. So we've got a chore, let's complete it. So we can say await db.complete chore, passing that same chore. So we're going to create that new chore. We're going to then, actually let's grab it back because this does not have the ID on it. So let's get rid of, well, we'll wait to get rid of that. So we will say db.getAllChores, and we'll say var chores equals await. There we go. Don't forget the await. And they can say chores.first. So complete the first chore in the list. That's all we'll do. Let's run this. And it's running, it's done, no errors. Let's go back to our compass. where we can see we have, let's refresh here. We now have a chore history entry, as well as on our chore chart, we'll have, chore history chart, we'll see who completed Tim Corey. Let's zoom in here. Tim Corey completed mow the lawn on this date and time. So that now has taken care of our chore history. What we didn't do was we didn't go in here and modify our last completed. We should have done that. Let's do that. So we're going to grab that first chore. Let's cut this out here, and we'll say var new chore equals like so. We'll say new chore dot last completed equals date time dot UTC now, just to be precise, and we'll say complete chore. So with that, we'll run this again. It's going to get already done by the time I open up my compass. So let's go to chore history. We now have 2 entries for mow the lawn. We go back to the chore chart and notice that last completed is that date. And I was assigned to Tim Corey. It's mow the lawn. The chore history, it's same chore. We completed, and we did it pretty close to one another. So that's how you work with MongoDB. We've gone through the basics of it, where we just, kind of dabbled in just an insert and a read, which was really, really quick. We could do that in a few minutes. But we then went into this, where we've got pretty much examples for anything you want to do. If you want to do just get everything, there's how you do that. If you want to get with a filter by looking up and only getting certain records, there's how you do it. You want to do a create, boom, there's a couple of options. You want to update, there's an option. You want to delete, there's an option. You want to do transactions, there's an option. So what this gives you is not only a good demonstration of how to work with MongoDB, it also gives you a reference to go back to say, how is it again that I do transactions, or how is it that I do an insert or an update? MongoDB is a great option for working with the data in your C# application. And as you saw, working with the cloud, super simple. You just have to have the connection string, and then you connect right to it, and there you go. So it works just like it does locally. So for testing purposes, using the cloud is perfect. And by the way, I'm using the free version of Atlas. I'm not paying for Atlas. I don't have free credits for Atlas. I'm using the free version of Atlas to do all of this. So you can see that I actually have 3 different databases out there that are being replicated, 3 different nodes. So this is taken care of for me. They update my databases. In fact, an update is coming in February of 2022 to Mongo 5. So that'll happen for me. It's all taken care of. It just works. So I would encourage you to check out MongoDB, see how it works for yourself, sign up for Atlas, use that link down below. It really helps make sure that people know that you came from me. That helps me, and it helps Mongo say, yes, this was good to help the community. And that's what we want to encourage here is MongoDB is being a great community servant. They're really helping out the community, not just saying, pay us. Now, they are a business. They do want to make money. That's great. That's fine. But they are helping the community, and they're helping us get started without having to have a big bill to work with. So I would encourage you to sign up for Atlas using that link. Tell them thank you. Watch the @MongoDB Twitter handle for that giveaway over the month of December. And then coming up in January, there's going to be even more cool stuff as they help pay for bringing a paid course over to YouTube for free so that you can learn much more about how to build a complete working production application using MongoDB. So again, tell them thanks. Thanks to them for sponsoring this video. And I hope you've learned a lot about MongoDB. Trust me, I would not show this off if I didn't believe in it. If you go back and look, I already have MongoDB content on this channel. It's already in my courses because it is a great option. All right, let me know what you think down below. Tell them thanks down below in the comments as well. I appreciate you watching, and as always, I am Tim Corey.